All right, in this set of graphs, you guys are going to be looking at the graph and answering questions that sound kind of difficult, but really aren't if you get down the idea of what a function is. When I say function, you say y. When they say graph or function, they're talking about the y value, but it's the x that determines the y value. So when we're looking at these graphs, okay, what I want you to do is, again, imagine that the x is like ground level, okay? X marks ground level, and you are able to get on top of this graph, get on this graph anyway, but first you have to go to the x and then jump up, okay? And then if you are on this graph, you always go left to right. So obviously, like if we could move right to left, we would be climbing up, but we never climb in this direction. Remember, we only walk left to right. This is a roller coaster that starts here and then moves to the right. All right, so here it goes. It says finding where a function is increasing, decreasing, or constant given the graph, interval notation. All right, we're back to interval notation, which is the whole thing with the parentheses and the brackets. But here, when they say function, they are talking about the y value. Okay, and remember, the y is the distance from 0. Now, the reason why I feel like I'm giving this kind of slow and kind of detailed is because it's a big change to go from y to f of x mentally. This means you have this function, okay? You plug in, we call that function f, we call it g. You plug in the x, f does something to x, and then it spits it out and you get f of x. Okay, but f of x just is the y. So in other words, we always think just in the same way that you graph a point as x, y, okay, it's x, f of x. Okay, so when you're walking along here, okay, the idea is that you go to the x and then understand that when you plug in a -5, wait, is that a -5? Sorry, I can't see very well. Oops, let's see. I think that actually is -7. Okay, when you plug in a -7, the -7 comes here through the machine. Okay, and what gets spit out, we plug in the -7. It goes into the machine, and what gets spit out is a 7. So it's -7, 7. Okay, what is the value of function? What is the value of the function at -7? 7. The value of the function is equal to y. Okay, this will click eventually, and then it'll be like heaven because you'll understand it. Okay, I'm just going to keep repeating it over and over though until it does. Okay, it says determine the interval on which the function is strictly increasing. Okay, gosh. Wow, okay. So you guys, I actually can't access the student view on this problem. The word strictly is really important. And I'm going to go look it up. I'm going to pause this for a second and go look it up real quick. I want to make sure. Okay, we might go through this in class, but here's the thing. I looked it up and it defines it as what I know, but it's not defining it as far as interval notation. So go back. Why are you here? Go away. Okay. So what I think, I do remember this being a problem last year because if you look, it says determine the intervals on which the function is strictly increasing. Okay. And that means when, imagine yourself, you're in this in this graph, okay? And you only move left to right. So here you are, you start at the top of the slide and you're like, ah, and then you stop and you walk. And then you, ah, and then you go up, right? Okay, so I think what happened last year, it says, write your answer as an interval or a list of intervals. When writing a list of intervals, make sure to separate each interval with a comma and to use as few intervals as possible. That is true, you guys. If you do not list the comma between the intervals, it will count it as incorrect. I'm going to pause this again because my kid is. Sorry about that. Oh my goodness. All right. So I believe what's happening here is that, okay, you can see that it's this interval where the graph is increasing. Take a look. Okay, again, where the function is increasing, the function means y. So look, you guys, first of all, it's easy to identify because if you imagine you're on the graph, you know that you're rising right here. So yes, you are increasing. But in terms of the value of the function, look, the distance from x is the value of the function. In other words, you'd have to go down 2. But look, you'd have to go less and less and less and less and less, right? Which looks like it's decreasing, but it's not because the value is going up. We were at like -4 here, at -4, and then we keep climbing, -3, -2, -1, right? So we are going up in value, okay? That's actually more positive. So if it's going more positive, it's increasing, which is more complicated than it needs to be. But here's the thing about the interval. This strictly thing, I'm pretty sure it means that when you do the interval, you don't put brackets. You put 2 and you put 3. Okay? Because what it's saying is that between x is equal to 2 and x is equal to 3, the function or y value, okay, the function is increasing, okay? The function is increasing. All right, the thing with the parentheses, I'm pretty sure that we don't know because it's turning at 2 and it's, right here at -4, 2, -4, and because it's turning at 3, -1, it's not really increasing at that point. So we put parentheses, okay? Just because last year I think I was doing brackets because I was like, that's a point. But yeah, I think pretty sure it is parentheses. All right, take a look. It says finding intercepts of a nonlinear function given its graph. This is a little bit easier because it says you basically are just looking for, does it cross the x or y axis? And that's it. This is the graph of a function is given below. Give all x-intercepts and y-intercepts shown. If there's more than one answer, separate them with commas. Again, really important. Click none if applicable. Well, obviously, look, nothing is intercepting the y-axis. So the y-intercept is none. Okay, x-intercept, pen, here we go. X-intercept, on the other hand, is, okay, look, here's your x, and you're going to look like, where does it cross the x-axis? And that happens right there at 3. Okay. I want to go, I don't think it has, yes. Okay, these are some important concepts. Looking here, if we were going to go, let's say they asked for decreasing instead of, oh my gosh, let's try this again. Let's say they asked for decreasing instead. Where is it strictly decreasing? Okay, you could see that you'd be falling right here. Okay, I'm pretty sure that point right there is actually a bracket because it's an end point. I might be wrong. You guys are going to have to let me know. You might need to have one of you guys open your Alex up and check this out. But I'm pretty sure you're going to get a bracket at -7 because remember, we don't care about we're not talking about the value of y. We're talking about x. We're asking the domain, okay? It's basically saying, where are you? Where would you have to go on the X to start and where would you finish? Okay, so this would be -7, comma, parentheses, because here we switch and we're changing and we don't know exactly what's happening for sure at that point. It's changing. So it's going to be -7 and -3. But that's not the only one. There's another one here. Okay, you're also falling here. So you're going to put open parentheses 0 because it's a connection point. Okay, why 0? Because it's 0 on the X. Remember, we're always talking about the X. We're looking at the graph and determining what are the values that you'd be plugging into this function. We'd be plugging in 0 all the way to 2, and that's going to make this function decrease. It's going down. So 0, comma, 2. See this comma? That's really important, by the way. Alex will get mad at you. And then the last interval that it is decreasing is 3, okay, because you have to go to 3 to get to here. 5, 6, oh, nope, it's 5. Okay, so here, between 3 and 5, here, the y value is also decreasing. If you don't want to say function, say y value. The y value is decreasing. Okay, so it's between 3 and 5. And that's the answer for that one. If they asked you for constant, it is constant when it's flat. The y value is constant. See, look, constant, constant, constant. You always jump the same distance. Okay, and it's between these two x values, which is -3 and 0. All right. Again, we might have to double check these. I just want to make sure they are okay. Okay, and here, okay, if you had another graph like this, oops, that didn't work. Let's try that again. Let's go here. Let's say we started here and we go here and then go here, 4, and then come down through 1.5, and then go stop here. Okay. And I asked you for the y-intercept and the x-intercepts. Okay. Normally you won't get these little dots. It's just because it's hard to hand draw, so it's kind of like indicating that it really does go through there. All right, in this case, the y-intercept on the red graph is 1, 2, 3, 4. The x-intercepts, there are 2 of them. You see them? There and there. They go through at -2, put a comma, 1.5. And it is fine. You use decimals in a real problem graph, okay? Moving on. All right, local max and local min. Honestly, they are exactly as they sound. Think of them as the top of the hill and the bottom of the hill. Okay, so here you want this roller coaster and it starts. You're like, up here, like my sound effects. Sorry, I don't do sound effects well. You know that part where you ride up the roller coaster and it's terrifying because you keep getting higher and higher. And then you get here and you can feel yourself weightless. And then you're like, ah, okay, that's me anyway. I'm screaming really loud. This top right here is called the local max. Local maxima. Max. Get it? It's the highest point you went. Okay, at that point. Okay, and then you go down. You're like, wah, and then you switch. Whoop. Okay, here, right here, is the local minima. It's the bottom. Okay, minima. There we go. Okay, so think of them as the hills and the bottoms. All right, so here's another local max right here. Because look, we go, wow, up and down and up. And here's the other down. So you have 2 local max and 2 local mins. Why are they called local? Because y'all, if you kept writing this, first of all, if you kept writing this to infinity, you would just keep getting higher and higher and higher. And the value of the function is increasing. In other words, the y is going up and up and up and up and up. That would be the real max. But the real max is infinity, so that doesn't make any sense. The real minimum is negative infinity, so that doesn't make sense. So we talk about local max and local min, where these little curves happen, and they mark they're called critical points. Critical points, especially when you get into calculus, these are really important. Critical points. It's the points where the graph changes direction. So go up, down, okay? Got it. All right, so the local max occurs at, oh, by the way, hey, look, this function is named h. So that function machine would be h. And it would spit it out here. Okay. And go in here. It always goes in on the left and comes out on the right. I don't know why. All right. Here we go. All local minimum values of h. So what are the local values of h? You guys, value of the function. When I say function, you say why. Why? Okay? So we're not looking at the x this time. We're not asking what x gives us that. We're asking you what is the value of the function. When they say value of the function, they mean the y value. Therefore, it is -2 and -1. And what are the local? Wait, yeah. Oh, okay. All local minimum values of h. Okay, it says all values, at which h has a local minimum. That means what values are they plugging into the function to spit out the minimums? Okay, that means you're looking for the x values. Okay, so in that way, we come here and the x value is here. The x value is right here. Okay, and so it's -1. Notice -1 is not on, -1, 0 isn't on the graph. It's -1, -2. See, if we plug in a -1, it's going to spit out a -2. And if we plug in a 3, it's going to spit out the -1. You get the idea? So if I plug in a -1, it spits out a -2. Okay? Just the words are really important, and they can be a little tricky at first. All right. Finding values in intervals where the graph of a function is 0, positive, or negative. Okay, so this actually is talking about the graph of a function. Again, okay, is 0, positive, or negative. It's literally asking you where y is positive, where y is 0, and where y is negative. Okay, you know this because look, x is the horizon. X is 0. Every value above, I don't know what color to pick blue. Every value above is positive. You're going in the positive direction on y. Any value below, you're in the negative direction. Agreed? In other words, like every single point here has a positive y value because we went up. It doesn't matter that the x is negative. We don't care. Okay? The graph is positive right here. So where is the graph positive? It's positive all the way here until we get to the x-axis. Then it is 0 at the x-axis, and then it goes into negative value here. Okay, the hardest thing to do at this point is to concentrate on the y. When they say function, when they say graph, when they say value of the function, all right, they're talking about the y. Okay, so let's read it. It says, use the function y equals f of x below to answer the questions. Is f of 3 negative? So find f of 3. That means f of x. You guys, that means x is 3. See it? X is 3. So all you need to do is walk to 3 and find y. Is it negative? Yes, it is. Okay, because we went down, we went underneath the ground. For which values of x? See the difference? See how it says values of x and not the values of the function? When it says values of x, they really mean find x. Is f of x 0? Okay, when they say function, you say y. They're literally asking you, where is y 0? Where is y 0? Where is y 0? It happens right there at 2. X equals 2. Okay, for which values of x? Again, looking for x. Is f of x greater than 0? Greater than or equal to 0? Greater than or equal to 0. Okay, when I say function, say y. So they want to know where it is greater than 0. It's going to happen here in the blue section, right? Okay, interval notation. Interval notation means you walk from left to right and name your exponents. So the first x that we have that's going to give us a value for y is -5. And then the last x is going to be 2. But remember, no brackets, because remember, 2 is also the 0 point. So, it says equal to 0. I'm going to say 2 open bracket. Again, you can let me know if I am correct or incorrect. It's a very specific Alex thing, and it's funny because I want to make sure that it's okay, but since I don't have access to the student part, it's hard for me to know. But maybe let me know. I feel like it should be a bracket. I mean, it should be a parentheses. But watch it be a bracket. Okay, and that's it. All right, that's it for Tuesday.